Geometric sequences are sequences in which you have a common ratio. So arithmetic sequences was a common difference. Geometric sequences is going to be a common ratio. When you hear the word ratio, what do you think of? What does ratio bring to mind? Difference is something, a subtraction problem, right? Ratio is a fraction. I usually think of fractions when I think of ratios, okay? So we're dealing with products, okay? Or division, multiplication or division when we're talking about geometric, okay? So with a geometric sequence, we're looking for a common ratio, a common number that's either being multiplied or divided by every term to generate the next one. So if we look at this first one, 6 times what gets you 12? 2. 2 times what gets you 24? 24 times what gets us 48? 2. So we know we have a common ratio of 2 in this case, okay? Because it's becoming larger, it's a whole number larger than 1. So our common ratio is 2. Make sense? The way to find it, if you're not sure, and this was easily visible, but if you take the second term and divide it by the first term, you'll get your common ratio. Okay, compare it to the third term divided by the second. Compare that to the fourth term divided by the third. Make sure that you're getting a consistent common ratio, and then you know it's geometric. Questions on this one? Okay, so let's find the common ratio for B sub n and for C sub n. Okay, top one looks like we're dividing by 3, right? So dividing by 3 is what for a ratio? 1/3. Because if we take 324 and we divide it by 972, we get 1/3. And 108 divided by 324 is also 1/3. So we see our common ratio. Okay? How about C sub n sequence? What are we going to use there? Negative. Close. Well, let's take our second term. Make it negative 1/3 divided by 1/2. When you're dividing by a fraction, what do? Multiply by the reciprocal, okay? So we're going to multiply by 2 over 1. Those go away, and we get negative 2/3. Okay, let's check and make sure that's consistent. If we take 2/9, not 29, 2/9, and divide that by negative 1/3. When we multiply by a negative 3 over 1, we're going to get negative 2/3. So our common ratio is negative 2/3. Okay? Questions on that one? All right. So now that we know about the common ratio, let's talk about the explicit definition. The explicit definition for a geometric sequence is a sub n, whatever term you're looking for, is equal to the first term times r to the n minus 1. First term times r to the n minus 1. Okay, kind of similar to that other formula I mentioned with my explicit definition of an arithmetic sequence. A sub n is equal to a sub 1 plus n minus 1 common differences. Okay, that's very similar to this one. Okay, we've got to back it off 1 because if we take r to the first power, we'll be multiplying it by a ratio to begin with, and we really need to back it off by 1. Okay, so let's look at an example. Okay, Okay, so let's take that 972, 324, 108, 36, 12, right? And we said that that ratio was 1/3, right? So let's write this as an explicit definition for it. We knew R was 1/3, okay? So our nth term for this particular geometric sequence is going to be the first term. What's my first term? Times R, which is 1/3, to the n minus 1 power. Now let's see if that works. Okay, if we want our first term, that's 972 times 1/3 to the 1 minus 1 is 0. Anything to the 0 power is 1, and 1 times 972 gives me 972. My second term is 972 times 1/3 to the 2 minus 1. 2 minus 1 is 1. 1/3 to the first is 1/3, and 1/3 times 972 gets us 324. Make sense? Okay. So questions on this one? All right. Then we have a geometric sequence. A sub n is equal to 3, 6, 12, 24, 48, and so on. And we're supposed to, first of all, A, find the common ratio. B, find the explicit definition. C, the 10th term. And then D, the recursive definition. Okay? So what's our ratio? Good. Okay? What's our explicit definition going to say? Yep. 3 is our first term. 2 is our ratio. So we take 2 to the n minus 1 and take that times 3. Okay? Now they want us to find the 10th term. So everywhere we see 10, n, we're going to plug in 10. So 3 times 2 to the 9th power. 2 to the 9th is how much? 512 times 3. 1536, is that correct? Okay, so that's our 10th term. And then finally D, the recursive definition. So recursive definition always has two parts. What's the first part? Back to your notes if you have to. The first term, right. So our first term was what on this particular problem? 3. And then it has a second part, a rule that relates all that, the previous term to the next term, right? So do you want to use a sub n plus 1 or a sub n for your definition? Doesn't matter. A sub n, okay? That means that a sub n is going to be equal to the a sub n minus 1, right? The previous term times what? Times 2 in this case, right? Times our ratio. So you can either put 2 in front times a sub n, a to the n minus, or a sub n minus 1, or you can put the 2 at the end. Okay? Ratio times the previous term. And take that previous term times the ratio times, and so forth and so on to generate all your terms. What questions do you have on this slide? Feeling good about it? Okay. Familiarity and comfort is all we have to do. Develop some confidence with these things. All right, so now we have a second term given and a fifth term given. And we're to find the sixth term. So similar to what we did yesterday when we were dealing with the 12th term and the 8th term of an arithmetic sequence. Okay, so we know, let's kind of just plot this out. We know the fifth term is 2/3. And we don't know the 6th or the 7th, but we know the 8th term is oops, I'm sorry, we know this, we know the second term. So the second term is negative 18. And we're trying to find the sixth term. Okay? So yesterday we asked how many common differences there were between them, but this time we have how many common ratios. From here to here is 1, here to here is 2, and here to here is 3. Okay? So if you look at your term numbers, 5 minus 2 tells us that we have 3 ratios. 3 ratios between them. Okay? So we've got to figure out what our ratio is. Okay? So let's think about that. Our fifth term is the same thing as our second term times how many ratios? 3. That means that we're taking it times r times r times r, or r to the third power. Okay? To get from here to here, we take it times r. We take that times r, and we take that times r, and we get this. Okay? So our a to the fifth is 2/3. Sorry, a sub 5. A sub 2 is negative 18, and we're taking that times r cubed. So how do we solve something like that? Divide by negative 18, which is the same thing as multiplying by negative 1/18, right? And then cube root. Okay? So 18 has what in common with 2? A 2, right? So that would be would reduce to 1/9. So what is negative 1/27th is r cubed. What will r be? Get all my colors going here. We have to take the cube root, right? So the cube root of negative 1/27th is what? Negative 1/3. So our common ratio is negative 1/3. Okay? So if we know that a sub 5, our fifth term, is 2/3, if we take that times our ratio, what will our sixth term be? Negative 2/9. Okay. So to clarify this and make sure you understand it, let's say that we knew the 7th term and the 11th term. Okay. A sub 11 is going to be equal to a sub 7 times how many ratios? 4, because 11 minus 7 is 4, right? So this will be r to the 4th. Does that make sense? Okay. And if we knew the 21st term, and we knew 22, 23, 24, 25, 26th term, make that smaller. How could we write an equation that would make sense for ratios for geometric sequence? A sub 26 is equal to the 5th, exactly. Okay, and then we can figure out what our ratio is. Okay, questions on this term, or this example, this topic? All right, next one. So we have two formulas for finding the sum of a finite geometric sequence, and one for the sum of a finite and one for the sum of an infinite geometric sequence. Okay, the first one is for the sum of a finite geometric sequence, and it says take your first term and take it times 1 minus r to the nth over 1 minus r. Okay, so let's put that into play. We want to find a finite sum. How do I know this is a finite sum? Yeah, it's got a 7. It's got an ending point, right? This isn't infinity, okay? So we are to find the sum of this geometric sequence. How do I know it's geometric? That's our power, right? Yeah, that's our power. So when we have a ratio or a power, the number to that power is our common ratio. Does everyone see that? 2 is being raised to a power, okay? So this is our common ratio, okay? So we're trying to find the sum of how many terms? 7. Okay, that means that we need to know the first term. So we're going to plug in 1. A sub 1 will be 2 to the 1 minus 1. Anything to the 0 power is 1. So A sub 1 is 1. So we're going to take that 1 times. Now let's do it. 1 minus, what's our ratio? 2 to the nth power, 7 terms, right? Over 1 minus 2. So we have to take 2 to the 7th, and we'll get 128, right? 'Cause 2 to the 8th is 256. So 1 minus 128 divided by a negative 1 times our initial term, a sub 1, and we're going to get a 127 for our answer. Negative 127 over negative 1 is 127. Okay. Now let's verify that that formula worked. Okay, so let's think about how this would work. If we let n be 1, okay, that means that we're taking 2 to the 0, right? Okay. So if n is 1, 2 to the 0 is 1. If n is 2, 2 to the 2 minus 1, 2 to the first is 2. If n is 3, we'll have 3 minus 1 is 2. 2 squared is 4. And then what do you think the next one's going to be? 8, and then 16, 32, and 64. When we add them up, what do we get? 80 plus 40 is 120 plus 6, 126 plus 1, 127. Okay? Make sense? All right, yes. Wow. Maybe we have something funky stored in X. We'll look at it. I'll remind me to look at it. Okay? All right, questions on this one? Okay. So let's look at the sum of a infinite geometric sequence. Okay? So this time we want to know how are we going to sum up something that's going to infinity. Now, the way that this happens is it only works when your ratio isn't fraction smaller than 1. Okay? Has to be a number between -1 and 1, not inclusive. Okay? Has to be converging on a specific number. So that's equal to a sub 1 over 1 minus r. First term divided by 1 minus the ratio. Okay, so let's see how that works. We want to find the sum as n goes from 0 to infinity of 5 times 0.5 to the n. Okay, so let's figure out what our first term is. If n is 0, that means that we're taking 5 times 1/2 to the 0 power, and we get a 1, so 1 times 5 is 5. Okay, now that's our first term. Our sum of an infinite sequence will be 5 over 1 minus r. What's our ratio? What numbers to the power? A half, 0.5. Okay, so 1 minus a half is going to be 1/2, right? So when we take 5 and we divide that by 1/2, what is that? If we divide, we multiply, flip and multiply, we'll get 10. So our answer is 10, which is much faster than if we did it the long way. Okay, because the long way says our first term was 5. Our second term will be, we plug in 2, 1/2 to the second power is 1/4. 5 times 1/4, I'm sorry, I didn't plug in 1. This was a sub 0. I messed up on my indices. So start from 0 to infinity, right? So a sub 1 will be 5 times 1/2 to the first. So 5 times a half is 2.5. A sub 2 is going to get us 5 times a fourth. So that's going to be 1.25. And a sub 3 will be 0.6, what? 0.625. 0.625. Okay? And then we keep going, right? Eventually, it will add up to 10. But you're much, much better off using this formula. Okay? Questions on this one? All right. So geometric sequence and the sum of geometric sequences, or the series. This is your assignment. And then we have a quiz tomorrow. Okay? So I'll have a review sheet for you in just a second. I will let you make a note card of any formulas that you want to use on your quiz tomorrow. Okay? So half the battle is just figuring out which formulas you want to write down, and then once you figure out which ones are important and you write them down, then half the time you remember them anyway and you don't need the note card. But I'll let you make a note card. And it doesn't have to be cardstock note card. If you don't have a note card, you just want to cut out a piece of 3.5, a piece of paper about 3 by 5, that's fine. Okay? Formulas. Yeah. That way you've got a listing and you don't get brain freeze or whatever. Oh my goodness, I'm on it taking a test and I don't remember anything.